We are the energy emperors, and we made an own English generator. This is what we did in the project, and this is about the team. Our dataset contains many old poems from various writers of the old age. This dataset is a result of the poems from poetryfoundation.com. It contains poems from subjects love, nature, mythology, and folklore that belong to two periods named the Renaissance and Modern. All poems are from poetryfoundation.com and are planned to be used for the purpose of some basic research. The poetry datasets consist of 576 rows of training. I'm going to pass it on to Jackson.
All right, so why do we choose to use GPT-Neo? We chose to use GPT-Neo for several reasons. The first being natural language processing. GPT-Neo excels in natural language understanding and generation tests. The second reason we chose GPT-Neo is because it's already a pre-trained model. GPT-Neo is pre-trained on a large corpus of text from the internet, which allows it to learn grammar, syntax, semantics, and a broad understanding of language. And the last reason we chose GPT-Neo is because it's a large-scale language model. GPT-Neo has a substantial number of parameters, enabling it to capture complex patterns and dependencies in data. And I'm going to pass it off to Sean.
All right, so for training time, originally we trained the model on We originally trained the model on the CPU and it took 10 minutes. And then later we switched it to the GPU with an expanded data set and it took 5 minutes. This is including the time it took to fix issues on our notebook or pre-processing. This is where we had to spend the majority of the time. The simple nature of the GPT-Neo model combined with our optimized training settings allowed for such a short training time. Passing it off to Vatsal.
So before pre-processing the data was not able to fit in the model's token limits due to the excessive lengths. Then after reducing the lengths of the data, for the MVP, we noticed hundreds of pad tokens being generated, which creates a negative impact on the model's performance. After training the model on this data, we noticed that the model kept starting with the conjunction and. Later, we applied a better pre-processing technique to yield better results. This significantly reduced the amount of pad tokens in lengths and to get better results. We modified many parameters as shown in the screenshot below. And passing that to Felix.
Yeah, so our model isn't exactly perfect, still generates some garbage and repeats, but it's way better than we had when we started, so I'm pretty proud of that. So here's some examples of what it generates. So for the first example, this is a prime example of what happens when our model repeats. So it says, you have not to thine pockets. The outputs, thy fancies, thy fancies, thy fancies. It does this a lot of times, but it actually gives some pretty decent results sometimes, like the ones you see at the bottom. For the second result, it repeats the word and, so it's repeating those connectors. And pretty much, it actually gives like a pretty good output for the second part. And for the third example, we just inputted some gibberish, and I don't know how you say it, but we just inputted some gibberish and actually gave a pretty good response for some reason. I don't know how it got that, but anyways, for the fourth response, we put in the moon is rising, and it outputted the stars are shining, the leaves are falling in the garden. So probably our best response. So in our journey of NLP, in order to make a model that's able to generate text written in Old English, we had to find a data set first. So the one that we found is comprised of many poems written in Old English, hosted on Hugging Face. We made a product spec containing a minimum viable product, a basic outline of the system, and our tech stack. Pre-processing our data was probably the main issue we had with our model, because there was a lot of pad tokens, as Vatsal said before. Took a lot of failed attempts, but it worked in the end. That's why we have this output. And it gave some pretty good results. We hosted the model on Hugging Face, and we put the model on a website using Flask, JavaScript, HTML, and CSS. So now I'll hand it off to Mason.
Okay, so as we said before, the model isn't perfect and it still has a few improvements. So for example, as we saw from the results, it still has some bugs and will generate random responses and repetition from time to time. This mainly occurs though when the user inputs incoherent text, but it's still something to fix. We had originally wanted to add a jokes dataset for funny responses, but we weren't able to find a usable clean dataset. We also realized that it might have problems joining data from two different data sets at the same time. But so far, the Old English by itself has been funny. That's the end of the slide, and we will show a demo. Okay, so this is the front end portion of our product. We used a bootstrap template and then edited it using only the elements we needed, mainly a title area, a short about page, and then the basic UI. This includes a text area for the user's input, a text area for the computer's output, and then a generate button. Okay, next, Vatsal will show the back end.
So this is the main Python file, which is actually the brain of the project. And right here, we have imported all the necessary libraries. Then we initialize the Hugging Face inference API to get the model responses. And then we're initializing the Flask app so that it can render the main index.html page. Then we're initializing functions so that the JavaScript is able to read and write the files so that it doesn't have to reload every time. And right here, this is the main generate function where it reads from the query.txt file, and it has all the text from the user prompt. And right here, we're creating the output by adjusting all the hyperparameters to get the best output. And then we're also using the same threading technique to simultaneously run the Flask app and to always run the generator function as well, which shortens the latency. And this is basically just hosting the app and passing it off to Jackson to demonstrate the project.
All right, so here is our web page. And so here's our front page, and we have an about section. Or give a brief explanation of what the model is and the team. And now here's the area where we prompt it. So I'm going to go ahead and give it an Old English prompt, and then I'll hit the generate button, and the output just appears here. And so that's about it. Thank you.